Hello guys, in this slide we are going to discuss 5G reference architecture. Okay, we discuss about the diagram. Okay, that is used for understanding the cloud native API driven nature for the 5G work. Okay, when you have to look into the Warshak trace, uh, like uh, to troubleshoot a failed call flow, or you have to configure routing and firewall rules between the different Kubernetes cluster. You need to know those specific end interfaces that you can see in there, like in this diagram. Okay, now we further divided into some parts. Okay, now let's see like this red nodes, or you can say these green nodes. Okay, so this is called access and user plane, and this is the physical path for your signaling and data. So here N1 interface is there, that is for NAS signaling. This is the logical connection directly between UE and AMF. It carries non-access stratum or NAS message used for registration, authentication, and session request. Even though it physically travels through the radio, okay, and logically to the AMF. Then we have N2, that is the control plane access. This interface connects the RAN to the AMF. It utilizes the NGAP protocol, that is next generation application protocol over HTTP to handle mobility, context setup, and paging. Then we have N3, N6. Okay, these are kind of the data path. Like once the session is established, user data flows from RAN over the N3 interface using GTPU to the UPF. The UPF then routes it to N6 interface to the external data network. And then we also have that N9 interface which can connect kind of two UPF together. Like for example, you have to connect an intermediate UPF at the network edge to central anchor session UPF. So then we have CUPS architecture. Inside CUPS architecture, we have one interface like N4, and like the nodes are SMF and UPF. Okay, and this N4 interface is between SMF and UPF, and like this is kind of physical implementation of control and user plane separation. Okay, now the SMF uses PFCP, that is packet forwarding control plane over the N4 interface to program UPF with the packet detection, forwarding, and QoS information rule. If your user has a signal but no data throughput, then N4 is often first place we need to check to ensure the UPF was programmed very correctly. Then we have the core control plane. We have AMF and SMF, and 11 interface is the interface between AMF and SMF. Like when a UE requests a new data session via the N1 NAS message to the AMF, the AMF forwards that request to the SMF over the N11 interface, so SMF can build the tunnel. Also, we have N14 interface. This is the AMF to AMF interface, and it is generally used during handovers when a UE moves from the tracking area of one AMF to the another AMF. Then we have authentication and state and policy kind of nodes. Okay, we can see here UDM, PCF, AF, and AUSF. So these are the nodes. Now we have N12 and N13 interface, N12 and 13 interface. Like during an initial attach, AMF talks to the AUSF over N12 interface to initiate authentication. The AUSF then kind of pulls the secure vectors from UDM over N13 interface. We have N8 and N10 interface. Now both the AMF and SMF need subscriber data. Okay. The AMF pulls mobility profiles from UDM over N8, while SMF pulls session management profile over the N10. We have N7 and N15 interface as well. Now PCF needs the rules. Okay, so a kind of PCF need to force its a kind of rules. Okay, now it pushes session level QS and charging rules to SMF over N7 and access and mobility rules to the AMF over N15 interface. We also have that N5 interface and the application function. Okay, now the AF interacts with the PCF over N5 to dynamically request some specific QoS handling the third-party services. We have some middle like slicing control or some advanced, you can say, nodes as well. So you can see here mm, an SSAF. Okay, that is network slice specific authentication and authorization function. Like it uses the interfaces N58 and N59. Okay, this allows a third party like an enterprise IT department, okay, to perform secondary authentication on a UE before allowing to access to their specific network slice. We have NSACF, that is network slice admission control function. So here you can see the interfaces N80 and N81, and it acts like a gatekeeper to monitor and enforce limits to the maximum number of registered users or activate PDU sessions allowed on a specific network slice at a particular given time. So that's it from this video lecture. I will see you in next lecture.